Galileo, a hero of science. How Galileo changed mankind's perspective on the world and space. In 1543, Copernicus proposed a radical view that the Earth was not the center of the universe in his book, De Revolutionibus. In 1559, the Roman Catholic Church listed prohibited books for the first time, including Copernicus's. This was the world into which Galileo was born in 1564. Many obstacles awaited Galileo. Aristotle's views on the universe became the Church's, thanks to Thomas Aquinas. Christians believed the Earth was the center of the universe. Around the layer of fixed stars was a sphere of the prime mover, and beyond was heaven. It was as if the prime mover controlled a large crystal ball with our solar system inside. Some Renaissance astronomers believed that changes could occur in the heavens. Scientist Tycho Brahe, without a telescope, saw a nova and Mars's orbit, showing that things could move. Brahe was convinced that there were more than solid spheres in the sky because he studied comets. The Catholic Church continued to suppress new ideas that contradicted their beliefs. Still, many people are asking questions. In 1600, Giordano Bruno was burned at the stake for following the teachings of Copernicus. In 1604, a new star appeared in the heavens, generating 3 public lectures by Galileo. The Church was listening. Galileo was always a devout Catholic, although he contradicted many teachings. His statement, "The Bible shows the way to go to heaven, not the way the heavens go," shows how he tried to justify his faith and his science. He believed God gave him the power to reason. I think that in the discussion of natural problems, we ought to begin not with the scriptures, but with experiments and demonstrations. These words would eventually silence Galileo. The key to all of Galileo's discoveries was the accurate measurement of time. That statement is true. Galileo's revolution in science is based on this. Measuring time allowed him to understand the fundamentals of motion. He said, "Measure what is measurable and make measurable what is not so." He circulated On Motion, a pamphlet, while in Pisa. Galileo proved Aristotle incorrect about falling bodies. Legend says Galileo dropped a cannonball and a feather from the top of the Tower of Pisa. His motion experiments in Pisa showed that 2 objects with different weights, when dropped from the same height, would strike the ground at the same time. Aristotle had claimed the heavier object would fall faster. To measure the speed of falling objects, he rolled objects down inclined planes. This slowed them down. Galileo discovered that all objects accelerated in proportion to time. Later, he found that objects propelled through air would follow a curve or parabola. The object would continue to advance forward while gravity pulled it down. Galileo, early in the 1600s, was timing motion. This invented a new way to study nature. Galileo's legacy lived on in Isaac Newton's laws of motion 45 years later. Newton credited Galileo with discovering the law of inertia, even though this was incorrect. Galileo had never managed to define inertia, although he came close. Measuring the rotation of the planets and gravity would be lost without Galileo. His persistent testing and mathematical proof were invaluable to future scientists who continued to measure the universe. In 1609, Galileo reinvented the telescope. Hans Lippershey in the Netherlands invented a crude one in 1608. Galileo heard of this from scientific gossip and called his a meager telescope. He improved Lippershey's tool. Galileo's telescope could magnify up to 20 times. The telescope added to Galileo's understanding of the universe because he saw things no one had ever seen. Galileo published a 24-page book about his findings. The book was The Starry Messenger. The Starry Messenger shocked everyone. This was just the beginning of Galileo's impact. Galileo described how he created the telescope. Along with the telescope, there were other important discoveries. The Starry Messenger showed what Galileo had seen in the heavens using the telescope. In January 1610, Galileo documented satellites orbiting Jupiter, the rings around Saturn, and the mountains and valleys on the moon's supposedly smooth surface, revealing great, unusual, and remarkable spectacles, opening these to the consideration of every man, and especially of philosophers and astronomers. As observed by Galileo Galilei, gentleman of Florence, professor of mathematics in the University of Padua, with the aid of a spyglass, lately invented by him, in the surface of the moon, in innumerable fixed stars, in nebulae, and above all, in 4 planets, swiftly revolving about Jupiter at different distances and periods, and known to no one before, the author recently perceived them, and decided that they should be named the Medicean stars. Venice, 1610. The rings around Saturn remained a mystery until after Galileo's death. Galileo thought the rings around Saturn were Saturn's ears. The first time Galileo saw the rings, they seemed to be 2 stars. 2 years later, Galileo was confused when the stars seemed to have disappeared. Io, Europa, Ganymede, and Callisto. Galileo also saw Jupiter's moons. Before this discovery, people thought the Earth was special because of our moon. No one was able to see Jupiter's 4 moons without a telescope. This again shows that by doubting what tradition established, Galileo expanded the world's knowledge of the universe. Thanks to the continued powers of modern telescopes, we believe there are 11 other moons in the Jupiter-Moon family. With all of these discoveries, Galileo shattered Aristotle's concepts with scientific evidence in mathematics, something that no single scientist had done. But with every success, there comes a conflict. Galileo was in trouble. Pope Urban VIII believed Galileo's theories jeopardized the Church's power. Galileo proved the Church was wrong about the universe. The Copernican theory stated that the Sun was the center of the universe, not the Earth. This is known as the heliocentric theory. By Galileo reviving that, the Church wanted to silence him, but he was too popular after his dialogues and his experiments on motion. Pope Urban forced Galileo to not write or speak about the Copernican theory. The theory was on the index of prohibited books. Copernicus was not a large problem to get rid of because he didn't have the proof. Galileo had the proof, basing his theory on what his telescope revealed. This threatened the Church. The telescope led to Galileo's house arrest. He officially recanted what the Church claimed was heresy. The Church seemed to silence this heretic. By allowing the Church to silence him, he conquered his conquerors. His discourses was quickly smuggled to Protestant countries in 1636, where they were translated and published without penalty. Under house arrest, Galileo still experimented and wrote. As Einstein later said, his aim was to substitute for a petrified and barren system of ideas the unbiased and strenuous quest for a deeper and more consistent comprehension of the physical and astronomical facts. Galileo's defying tradition is as important as his inventions. His discoveries are everlasting, his writings used by scientists who continue Galileo's legacy. After Galileo's death, his theory about our universe was taken as truth. In 1992, Pope John Paul II vindicated Galileo. Galileo believed mathematics was the key to nature. This changed the way scientists approach the unknown and how we understand the universe. Galileo affected history like no other. Today, everyone benefits from what Galileo began.